Okay, so let's switch to slide 8 now, and this is just a little reality check because this is from this one paper that came out last year. The probability distribution function of how sensitive we are to the greenhouse gases we've already got in the atmosphere. How much committed warming are we in for? And how much are we in for? What's our best guess? What would you guys say?
A little over 2.
Just over 2? Do we, that 2 degrees C cutoff, is that where we want to be, or do we want 3 degrees C cutoff? Usually, when people talk about those numbers, 1, 2, 3 degrees C, they're talking about temperature rise since the Industrial Revolution. So then in your heads, you kind of have to take, okay, we've already had 0.7 of a degree C temperature rise, and you have to subtract that. The oceans are out of equilibrium with the atmosphere, and they've got that stored heat in them, which just isn't letting the planet lose heat at the rate that it would it's hard to say at a different, like without the oceans, because there is no without the oceans. But there's just so much heat that's in the system that we're kind of hiding from ourselves right now that then is going to come back and bite us when we actually like stop pumping any more in. Like right now we're like, because we're so on the up and up and up, like the oceans are still trying to play catch up, like they're always behind us. But only when we like shut it off and stop like moving on this upward track do they get a chance to like catch back up with us, and then they really catch back up with us.
And when will the oceans hit that capacity where they can't continue to take in this heat?
They won't.
So
pick ass,
the
just one sec.
system is going to naturally go towards equilibrium between the water and the land, but because the ocean heats up more slowly and cools down more slowly than the land, right now it's absorbing heat from the atmosphere, trying to get up as hot as the atmosphere and the land, and then later after the atmosphere cools down, then
the atmosphere won't.
To it.
Yeah, the atmosphere. Yeah, but it's not that the atmosphere will actually cool down. It's that once we stop continually like heating and increasingly heating the atmosphere, then it gives the system a chance to get back into equilibrium, and that's when it's going to find an equilibrium that's higher than it would have been if the oceans weren't in the picture.
Right. Okay.
Yeah, I think you guys. This is a really tough concept. I think. Spend some time. I guess I would say let's try to move on, but spend some time thinking about it. And like, if you guys still have questions conceptually, let's get back in touch. And then Pick also asked. Well, do you want to ask again? So, Pick also asked, when does this ever stop? Do we ever maximize and just max out how much heat the oceans can take up? And the answer is no, we never will. This graph here, what are we on, slide 8 still, kind of gives us a sense that we've got commitment warming in the pipeline that amounts to over 2 degrees Celsius. And this is relevant particularly because over 2 degrees Celsius is often what people talk about in terms of like, that's where we want to be max. We don't want to go over that. And this, according to this, we're already there. Like, we're already committed to that. So that is an interesting framework to have mentally, like going into Copenhagen. And for all of us, everything that we do, thinking, oh yeah, we're already there. We don't have any more wiggle room. So now let's look at these IPCC reasons for concern. So this is slide 9. And this one is, so the one on the left, and this is the only one we've got up here now, is from the third assessment report in 2001. And so there's the 5 reasons for concern, and then they use these colors to symbolize the risks. So white means low or no risk, the yellow is significant risk, and then red is substantial or severe risk. And I think this is just a great graphical way to show, like, okay, you can kind of look at this and say, on the right there, on that temperature axis, like where would you want to draw the line in terms of cutoff for raising temperature and not want to get too much into the red zone. So this was for 2001. Before we talk about drawing the line, let's look now at the update. And this came from that new publication that came out this year in Proceedings of the National Academy of Sciences. And they took all those reasons for concern and they updated them based on the science that we know now that we didn't know 2001. Are you guys on the phone with me? So I think to see this, the right half of the slide, you have to go into your, actually into the slide view and then do the animation to get rid of that black box so you can see it.
Wait,
and
when it says past.
I know. Yeah. So looking at the temperature, just take a note of the temperature scale on the right there. So how I said that usually it's measured compared to pre-industrial, these guys did it differently. So their 0 mark is today. And so they've already subtracted out the 0.6 that we've had already.
Okay.
Yeah. So their 2 degrees C on this graph is not the same as the generally talked about 2 degrees C, which is compared to pre-industrial.
What's the year difference in these two?
The one on the left is 2001, and the updated ones is this year.
Okay.
Well,
Yeah.
it's about so.
Nope, this is from the Smith et al. Paper this year.
Oh, cool.
Yeah. So before we get into where we want to draw the line here, and I think we should talk about where we want to draw the line, let's talk about the why. Why did it get so much worse? So now we're on slide 10. Okay, and so there's some specific reasons that what we know now that we didn't know then that have made it worse. The first one is that there have been more observations made of impacts that are already occurring. So this isn't model results, this is actually seeing what's happening at the temperature that we're at now. And those include, and for those of you guys on the phone, this is in the notes section here, some of the specific learning since 2001 for each of these reasons. Impacts in Arctic and mountain communities, particularly the pine beetle epidemic has shown, sensitivity at temperatures that we're at right now, killing all those trees in western U.S. and Canada. And then the big events, particularly the 2 big events were Katrina and the 2003 European heat wave, showing that we are already at a point where we can have some of these massive events. So the second one is higher confidence in the future impacts and when we can actually hit those future impacts. And those include ocean acidification affecting coral reefs, species extinction, and then research showing that floods, droughts, and heat waves in particular can have significant risks starting at just 1 degree C more.
And that more confidence comes from actual observations, or
Now we're in the model realm here.
why
Yeah.
are they more confident now than they were then?
I think that's a good question. I think better models, and then so Ashley asked what makes them more confident that those future impacts are going to happen, and I think it's a combination of better models and then basing those models on the first one there, which is the observations. Yeah, so you're probably right. It's a combination of the two. So floods, droughts, and heat waves having significant risk at just 1 degree C more warming. And then the third one is, and this is important too, better understanding of how vulnerable we are. So it turns out, we've realized, particularly because of Katrina and the 2003 heat wave, that we're more vulnerable than we thought because we actually had these math situations where we tested it. Yeah, Alicia?
I have a question. I'd be curious to learn if there was a better understanding of the impacts of shifting seasons and things like that, I don't know, it just says maybe further reading or things like that, things that seem subtle but also make us really vulnerable, even though they're not a
so
storm.
Alicia was asking about better understanding of things like seasonal shifts. And I don't know, I wonder...
Can you repeat that, Rebecca?
So Alicia asked if there's also better understanding of shifts to seasons. And I know in some ways I think in some ways this sounds bad, but this has to be dire enough and serious enough to go into the category of dangerous climate change and fit into one of these categories.
But isn't that there's hurricanes all the time that would happen in the middle of the ocean, but because they're not damaging us, we don't take stock in how serious they are, right?
Right.
It's the same kind of thing.
Right, because hurricanes is on one of these reasons for concern, extreme weather events.
Mm-hmm.
It seems like
I don't know, where would you put seasonal shifts on
risks
there?
to unique and threatened systems.